Hey everybody, welcome back to part 2 of our Minecraft Tower Defense coding tutorial. Today in part 2, we're adding zombies, creepers, and spiders. If you haven't watched our part 1 video where we set up our underground mining system, stop everything and watch it right here. But if you want to start coding from right here, grab our Scratch catch-up file, which has all the code that we set up in part 1. You can find in the links down below in the description. Make sure to like and subscribe for more amazing Scratch tutorials. Let's get right to it.
Okay, we're going to start coding here in just a minute. I'm looking at my catch-up file. So this is a file that I'm distributing that has all the work that we did way back in part 1 in here. So if you're impatient and you just want to get to the stuff that we're coding in today's file, or if you are having some trouble coding the first section, I heard back from a couple of users who had put some blocks down wrong and they were frustrated that their file wasn't working. Well, the option here is to just download my finished file, the already cooked part, and then you can continue building from there so you don't have to get frustrated. So let's get into the file right now. If you're looking for this, you can find it on my website. It's called a catch-up file, as I said, for Minecraft, and you can also find it down below in the file description as well. You can find the link to that. Okay, so today we're going to be coding the zombies, who are bad guys in the game. But before we do that, we want to be able to put down the blocks that are going to that we're going to use to stop our zombies from approaching our base. You can see in part 1 we already coded our mining system, where we can dig down into the ground, grab the stone and the gold that's down below here, and dig these ever more elaborate tunnels into the ground, all the while fighting off the zombies who are trying to destroy our base as well. So you can use these resources that you've harvested to build bowmen, who you can use to defend your base, or you can build blocks that you can use to prevent the zombies from attacking you. So let's get to building those wall blocks now. So I'm coding the wall block section. The code's not too difficult here. We're really just asking a bunch of questions. We're going to put down a block, but only if certain conditions are met. For example, we can't put down a block on top of the existing house on our screen here, so we need to check that we're not trying to place it on top of a house. We have to check and make sure that we're not placing it underground. We have to check and make sure that we're not placing a block down so that it's suspended in midair. There has to be a block down below it, or it has to be the first block that's touching the ground. We have to not place it on top of an existing block or on top of an archer block as well. So we're just going to be checking for all those different things using a whole bunch of code, and if all of that checks out, then we can create a new clone of our block and place it down on the screen. So let's get started with that. We're going to grab a green flag, events, when green flag clicked. So we're going to be wearing a different costume here for most of the time. It's called a probe, but just a little red dot that's arranged over on the in the center of this 16, well, actually on the bottom right hand side of this 16 block object. You can see that the cobblestone block here, again 16 pixels, and the center dot here is arranged right at the top left of this object. So we're going to create we're going to transform this block while we're placing it down to this other little red dot block. And that way we can start to check collisions. We're going to basically use this dot and see if it's overlapping on top of an existing cobblestone block or overlapping on top of anything else. So we don't want the whole block doing the collision detection, because we could accidentally be touching something. So we make it a fairly small little block here, and that way we can just teleport it around the screen, check below, check to the sides, make sure everything's cool, and then and do the collision detection a lot more accurately than if we were using the whole object. This all happens so quickly that no one really sees what's going on here, though. For all intents and purposes, this is going to be invisible until we actually make it appear as a proper cobblestone block on the screen. Okay, so when we click the green flag, we're going to switch the costume, looks, switch costume to probe. So we're going to turn into that little red dot that we're going to be poking around the screen. We're going to set the ghost effect, set color effect, change it to ghost, and change that to 99. Now, I've explained this in many different videos before. Setting ghost effect to 99 is a really cool function because it makes the object basically invisible, but it can still collide with things. Invisible objects, you can't check collision detection on them, whereas if the ghost effect is 99, you can. So it's a little hack we use to have invisible things probing around the screen to see if they're touching anything. All right, let's grab a forever. And what we're going to be doing here forever is basically waiting for a mouse click and then placing this sprite down on the spot where we've clicked. You might remember last week that we did a fairly elaborate code here. Let me grab a go to XY block that basically takes your mouse click and converts it to the grid here. And we used some fancy math with rounding numbers off to make sure that wherever we tried to place an object, it was always aligned with the grid. You can go watch last week's episode for a very detailed explanation of how I did that. I also talked about it on my live stream. But basically, we're using we're using rounding off numbers, using the floor and ceiling command to place these things, absolutely. So I'm going to grab this object here called floor. I don't need it quite yet, though. The first thing I want to do is grab my mouse X and my mouse Y, which I can find under my sensing blocks. So let's go to sensing, and we'll grab mouse X, mouse Y. That will tell us the X and Y coordinates of our mouse. We'll start with mouse X here. And we'll say mouse X divided by 16, which is the width of our grid. So we take our mouse coordinate, we divide it by the width of the grid. Then we round it off. We grab its floor. So if I'm not exactly aligned with the grid, we're going to get an odd number, 16.2 or whatever, and we're going to round that down to 16, and that will bring our object over so that it aligns perfectly with the grid. But first we have to multiply it by 16. And that will make that number match up with what it was originally, just round it off. All right. And I think that's actually all we need here right now. So let's go grab that, plunk it in the X coordinate. Now the Y coordinate's a little bit more complicated. We're going to grab okay, so because the grid is a little bit offset here, we're going to subtract 4 from the Y coordinate. So mouse Y minus 4. Then we're going to divide that by 16. So divided by 16, just like we did in the mouse X. Then we're going to grab the ceiling of that instead of the floor. So I'm going to go to my math blocks here, grab this one here that says ceiling and pump that in there. Then we're going to multiply it by 16 again. And because we subtracted 4 a second ago, we're going to add 4 at the end as well to make it all properly align. Whoops. Try that again. Plus 4. So this entire big block, let me show it on the screen. You can freeze frame if you're having trouble with this. All right. Let's plunk that into the Y coordinate there. So all that is doing is making sure that our blocks align with the grid. Let me temporarily change this ghost effect to 0 so you can see the object on the screen here. Let me click the green flag. You'll see that our dot is now appearing on the screen, and it's always snapping to that grid. So no matter where it goes, it will only stop when it's perfectly aligned with the existing grid. Okay, so far so good. Now we're going to detect our mouse click. So we're going to grab an if statement, and then we're going to start checking for all those different things I was talking about that we're checking that we have to determine before we're allowed to put a block down. So let's go if mouse down. That's in our sensing. Now we don't want to plunk it down yet because we need a fairly complex series of green blocks here. So let's grab an and statement. If mouse down and, then we're going to need a not. Let me just put this down here and we'll get it all set up and then I'll explain it properly. So we're going to put a NOT inside there and we're going to put an OR inside there. So we're checking if our mouse is down and two of these things aren't true. We're looking for either of these two things not being true. And if those two things are not true, then we can go ahead and check for our next thing. So what are the two things I'm looking for? I'm looking for to see whether it's touching the archer. So let's go grab touching archer. Oh, sorry, that's a color. Grab the wrong block. Touching archer. So we cannot put a block down on top of our archer. I'm going to put all that inside the if statement right now. And what goes in the other OR? Well, we also want to check whether we're touching another clone of the wall block. But we're going to run into a little trouble here. When I go touching and I look for the wall block, it doesn't exist on this list. Bonus points for anyone who can figure out why not. The reason is because the wall block is the object that we're actually on right now. So this is kind of a little bit of a bug in Scratch, but the creator of Scratch thought you can't detect whether you're touching yourself, so they didn't make an object able to detect whether it's touching itself. But of course we can make copies of our objects, clones of them. So we do in fact need sometimes to know if we're touching a clone of ourselves. So there should be an object here that says wall block. There isn't, because we just cannot get that while we're on wall block. So there's a hack we can use to fix this problem, though. I'm just going to go to the next sprite, my zombie. I'm going to grab that touching block. And in here, I do have touching wall block. That's an option. So I'm going to drag this sprite over to my wall block. This block over to my wall block. I'll delete it now. And now, because I created another sprite, I'm allowed to detect whether I'm touching wall block. That actually does work in the code. Let's trash the other one. It's a weird workaround to a problem in Scratch, and it does in fact work. Okay, so we finished our first round of checks here. We've checked to see if our mouse is down, and if we're trying to put our block down on top of something that we're not allowed to put it on top of, an archer or an existing wall block. Next, we're gonna check below us to see if we're trying to place our object at ground level or on top of an existing block. Those are the two places you're allowed to place blocks, right? You're allowed to place them just above ground level, and you're also allowed to place them on top of existing blocks. So if we look at the block down below us, if we move 16 pixels down and probe in that direction, we can see whether we're in the proper spot. So first of all, we have to take our probe block and move it down. So we're going to go change its y coordinate by -16. So that will probe down in the block right below the block that we're trying to place, and it'll see what's there. So we're going to say so we need another if statement right below there. So after we finish moving down with our probe, we put an if statement in there. And again, we're going to check and see if the block below us is touching a wall block. So I'm going to duplicate this. I don't want to go grab another wall block touching from the other sprite. So I'm just going to duplicate this one with a right click, plunk it in there with an OR statement connecting it. So let's grab an OR statement from our operators. So if the block below me is a wall block, or if it's below ground. Now ground level is at a y of 55, so if I say if my y is less than 55, I'm going to put a less than sign then there and go to my motion blocks and grab a y position. So if my y position is less than 55. But what if I'm clicking deep underground, right? These conditions will still be true. My y position will be less than 55. Well, that will all get corrected in the next level here. We're going to check and make sure that when we move back up again that we are above ground level. So first we're checking if the block below us is below ground level, then we'll check if the block that we're actually on is above ground level, and that'll kind of filter out all the clicks that we get that are further deeper down in the ground so that we can't place a wall block underground. Okay, so we've checked for the two things, for two more of the conditions that we need in order to place a block, right? We're checking to see if if we're trying to place a block on top of an existing wall block, that's good. Or if we're trying to place it at ground level, okay, or at least below ground level. All right, so now we can, if all that is true, then we're going to move our probe back up again and continue checking the block itself rather than the block below it. So we're going to change our Y by 16. So we've passed that next test. And now we can do another if statement here. So again, it's like a filter. We keep checking to see if certain conditions are met that will allow us to place a block. All right, now we're going to check to see if we're trying to place a block on top of this existing house structure in the middle here. Now we can tell where it is by its x-coordinates. Its x-coordinates are going to be between a certain value range here. And we're going to say you cannot place a wall block if you're trying to put it inside this house. So let's do that. And to do that, it's another fairly complicated series of blocks here. We need an AND block inside that if statement. And on the left side of that, we're going to put an OR block. Once more, I'm going to fill in these blocks and then I'll explain them to you later. So on the left side of our OR statement here, we're going to put a greater than sign. And then on the other side, we're putting a less than sign. And then we're going to put a greater than sign after the AND. Okay, and so the first two spots here, we're checking the X position. I'm going to grab two X position blocks. And in the third spot there, we're checking the Y position. So we're checking the X position is greater than 33 or less than minus 55. And our Y position is greater than 54. Whoop, I put the Y in the wrong place there. If our Y position is greater than 54. Okay, so the Y position is greater than 54, as I was hinting before. We're checking to see if the block that we're actually on is above the ground. So we check to see if the block below us was underground. Now we need to check to see if the block that we're on is above ground. And we also want to make sure that it is to the left of this line, which is where our X is less than minus 55, or to the right of this line, which is X is greater than 33. So if we're clicking above ground and not on this house, then again we pass the next layer of testing we have to do to make sure we're allowed to place a wall block. All right, so we have one more layer to go. We're going to add an if statement inside this if statement, and this is the last thing we have to check for before we can actually place our wall blocks here. And that is going to see whether we're going to check for two more things here. Number one, we're going to check and see that we've actually selected place a wall block here, because otherwise we're going to be placing a Bowman in this spot here. So we want to make sure this is selected. And we also want to make sure we can afford it, that we have enough rocks in our inventory to gather the thing. So I'm going to, inside this if statement, I'm going to be checking with an AND statement again. And I'll be checking both those criteria. So if on the left here, we're going to say if our stone collected, the amount of in our inventory, is not less than 3. Now that's an interesting construction. We could say, you'd think we want to say greater than 3, but we actually want to say greater than or equal to 3. So this is a clever way of saying greater than or equal to, which is a block we don't have access to in Scratch. So if not, if stone collected, that's our variable that's keeping track of how much stone we have. If not stone collected less than 3, so if our amount of stone is greater than or equal to 3, and our defense block selected, so that is just a variable, and we'll put an equal to sign there. So that's a variable that keeps track of which of those buttons up at the top we have selected. So defense block selected means that we've clicked on the green object here at the top that toggles back and forth between building walls and building archers. So if defense block selected is equal to 0, sorry, defense block, I guess, is the arrow block. So if we haven't selected the arrow block, then we've selected the wall block, right? So that's what that variable is keeping track of. So, okay, so we've passed our last layer of checks here. And if all of that stuff checks out, if we're placing a block in the correct location, then we can go ahead and create a clone of ourselves. So we're going to create a clone of our wall block. We're going to play a sound here. So I have a sound effect that is called stone placed sound. Just kind of a thumping sound, again, ripped from Minecraft. And then we're going to take away from our inventory the stone that we just got rid of. So that's 3 blocks of stone. So change stone collected by -3. -3. There we go. So I think we're in a position where we can finally test this. We do need to know what happens when I start as a clone, though. Otherwise, our clone's going to remain invisible, and it's going to be on the wrong costume. So let's go control when I started the clone. And we'll say, first of all, we want to get rid of that ghost effect. So we're going to set it to 0. We'll go to looks, set ghost effect to 0. We had it at 99 a minute ago. Then we're going to switch our costume to cobble, which is the actual rock costume. And we're actually good to go here. So let's give it a try. We'll click the green flag. And you can see that I have enough stone here. I have 5 collected, so I'm going to... Oh, I switched that little red dot to make it visible. It shouldn't be visible. I'm going to go back up to the top and set that ghost effect back to 99 here again. All right, one more time. Let's try this again. So yeah, now I don't have a dot anymore. Let's click the green flag and I can start to mine resources. I have enough resources, so let's just click here where I want to put my stone wall, and good, that works. So I'll dig a bit more stone here. I've got 5 stone here, enough to lay my next block. Let's try to place it underground. That doesn't work because my Y coordinate is too low, but I can place it here. There we go. Let's mine a little bit more resources here. We've got 3, which is exactly enough. Now I'm going to try to place a block on top of a block. Let's do that. And there we go. Good. Now let's try to place a block on top of that. Oh, it doesn't work because I don't have enough stone. So you can see here that our wall building system is actually working nicely here. Let's get 3 more stone. And so this will allow me to build these walls up as high as I can to the top of the screen here. Not build them underground, not build them on top of anything that's already there. Perfect. So our wall building system is working beautifully. We are ready to move on to zombies. Woo! Okay, so we're over in our zombie sprite now, and we're going to start by spawning them at either end of the screen, and they're going to very slowly walk towards the middle. Their actual movement speed is only 0.2, so they're just going to very slowly move across the screen, all the while checking to see whether they're bumping into a wall that you've created for them, and later on we'll be checking to see if they've been hit by an arrow as well, of course. So let's get started with that right now. Let's start with the spawning system for starters. So let's go grab a green flag. Now we're going to set our rotation style, motion set rotation style, which is way down to the bottom of the blue blocks to left, right. That's going to stop our zombies from flipping upside down if they're facing to the left because they're starting on either side of the screen, and we're just going to use a move command to move them towards the center. So if we don't have this left-right initiated, when they're moving to the left, their bodies will be upside down. Always a problem in these kinds of games. All right, we're going to clear graphic effects. Looks, clear graphic effects. And that's just going to get rid of any... Well, later on we're going to be turning these guys red if they're injured. So we just want to make sure that we start off with a clean graphic that doesn't have any of those kind of effects on it. Then we're gonna do a hide because our master clone object zombie object here isn't going to be visible. You're just going to be making clones invisibly. All right, so let's go ahead and make clones. We'll put a forever here. And we're going to make a clone every 6 seconds. You can modify that if you want the game a little bit harder, but 6 seconds works pretty well in our play testing. And after 6 seconds, we'll create a clone of ourselves. So that's a good pace that allows us some time to do some mining before the bad guys actually start to appear on the screen. Okay, so what do the clones do? When I started the clone, we want to be visible, of course. Let's go to our looks commands, do a show. Let's set some variables. We have some local variables here. You'll remember local variables when we're making clones apply to each one. So when we set health points, I've already created this variable, but when I created it, I clicked for this sprite only. And that's a little bit of a more advanced function that you new scratchers won't have seen. But the advantage of that is when I go set health points to 2, it gives every single clone his own health points. That's the benefit of using local variables. And so we can have each of them hit twice before they die. There's another variable here called set red frames left to 0. And red frames just means when when your zombies get injured by an arrow, they're going to turn red for a second just to give the player some feedback that they actually scored a hit. And so that's how many frames of animation are left before that red reverts back to the normal green color of the zombies. Okay, now we're going to pick a random number here. Let's do an if-else statement, control if-else. And we're basically going to flip a coin here. So we're going to go if pick random from 1 to 2 is equal to 2. So we're going to pick a random number from 1 to 2, flip a coin basically. If it comes up at 2, then we're going to go to the left-hand side of the screen. So let's go do a go to command. We're going to put 1 in both those positions just to save some time here. So on the left, it's minus 237 by 52. And on the right, the else is positive 237. If we're coming up on the left hand of the screen, we want to be pointing right, pointing direction 90. And if we're on the right hand side of the screen, we want to be pointing left, direction minus 90. Okay, so we're starting to spawn our characters. Now, we're going to have them change their costume on a timer. We can't just go next costume because one of the things we're going to be doing every once in a while is changing. So we've got our zombie moving costumes here. These are ripped right from Minecraft. But every once in a while we're going to change back to this costume here that's just a probe to check if we're touching a wall or whatever. So rather than just doing the next costume, we're going to have to keep switching costumes. Okay, so we'll start our animation loop with a forever here. We're just going to keep going around switching costumes. We're going to switch costumes every 5 frames, so we're going to keep track of that using a variable called costume timer. It's another local variable. It applies to every single sprite, or individually to each sprite. We're going to change that. Let's go to variables, and we're going to change that costume timer by 1 every time we come around this loop. And every 5th time, if costume timer is greater than 5, we'll grab that variable, costume timer. So if our costume timer is greater than 5, then we're going to set it back to 0 again, set costume timer back to 0, and we're going to switch to the next costume. So that'll ensure that we only change costume every 5th frame of animation, or every 5th time around this loop. And then we want to make sure if we land on that probe costume, which we don't want to actually see, so we'll say if costume name is equal to probe, we'll grab an equal sign. Let's go to our looks command, and we'll grab a little bubble that says costume, not number, but name is equal to probe. We'll actually type the word probe here. Then we're going to switch back to the first costume. So switch costume back to the first one on the list here, which is actually called the Minecraft Zombie 2, ironically. Alright, so this is going to cycle through the costumes. We're just going to go next costume every 5th time around this loop. And then we're going to, when we get to a probe, we'll just skip that and go right to the first zombie costume. Okay, now we're going to be popping back and forth between these, between that probe costume and the other one. So we need to keep track of what costume we're wearing when we switch to a probe so that we can go back to it again and continue with our animation. So we've got a little variable called temp here, which I believe is also a local variable. No, actually it's not. It's just a global variable. So we're going to set, so we're inside the forever, but underneath the if statement, we're going to set temp to whatever our costume number is. So let's go to our looks commands and we'll grab a costume number. So that'll just remember what costume our zombie is wearing and store it in that temp variable just long enough for us to process our move, and which involves probing back and forth with that little dot, and then we'll switch back to the original costume again. So while we're now that we stored our costume here, we can switch to, so let's go switch costume to probe. And then we're going to do our move cycle here. So I'm going to create a custom block here for this character called move. We don't have to select any options here, just click OK. And this will cover our movement cycle here. Basically, I'm not going to trouble myself with that right now. We're just going to keep going here. So after we're done moving, let's drop the move block right in here. Then we're going to switch our costume back to temp again. Switch costume to, and we'll put the variable temp in there. So after we've processed our move, which involves switching, turning to a dot, checking in front of us, checking above us to make sure that the zombie is able to actually move, then we can switch our costume back to the one we were wearing before we became a probe. Okay, so the next step in the life cycle of our zombies here is we're going to check and see if they've been hit by an arrow or damage. We're going to make another custom block for that, make a block. We'll just call it check for damage. We're going to deal with the details of that later. One thing I do want to say, though, is this is one that's going to run without screen refresh. So we're going to want to click on that little checkbox there so that all of this happens instantaneously without changing frames. So this entire thing will run within the same frame of animation, and that's important. Sometimes that will screw you up and sometimes it won't, and I wish I could give you a hard and fast rule for when you want to do that with your custom blocks. It just takes a bit of experimentation to get used to it. Okay, so we're going to add that block, that new custom block down below here, check for damage. And after we check for damage, our hit points go down. Let's just do a quick check to see if our hit points are sufficient to kill us. So I'm going to go with if less than, if our health points are less than 1, then we have a new custom block here. So let's go back to our custom blocks. We'll add a new one here called a die. And that will take us through a death animation for our zombies. So let's add that down below. That one doesn't need that run custom. This is the only check for damage is the only one that needs that. Okay, so we've got the basic skeleton in place here for the life cycle of our zombies, moving, seeing if they're hurt, and dying. The moving includes climbing walls, which we'll get to in a minute. So we're going to program the moving now. I think we're going to wait with the check for damage and die until we're actually able to damage our zombie. So that's going to mean we're going to have to get our bow and arrow in place. So just for the sake of keeping this organized and being able to actually show you guys what's happening, I'm going to wait and move to some other stuff. But let's get the movement going right now anyway. So we'll go to the define move block that we just created. And let's code what happens when we move. And As you might have guessed, again, we're probing here. We're just going to be moving ahead and up and down and seeing what's in front of us before we move. So our first step here, as I said, is we're going to move 6 steps. That's not a real move. As I said, we're popping forward to see what's in front of us. Then later on, we'll pop backwards back to our original location again. So we're just going to see what's in front of us. While we're here, we want to turn our gravity off. So let's go set gravity this frame to 1. Sorry, we're switching the gravity on. We're making sure that it's on here. But if we're climbing a wall, we're going to turn it off. You're going to see that in just a second. So first thing we're going to check and see now that we've moved forward is, are we touching a wall block? So if touching wall block, if we're touching a wall block, well, the next thing we want to do is see, is there a stack of wall blocks, or is it just one wall block? Because that makes a big difference. We can climb a single block, but not a second one. So we're going to probe upwards now. We're going to change our Y by 16 and look at the block right above the existing one that we're on top of right now. And in this case, we're going to do another. Oh, by the way, this if statement is actually an if-else statement. I just caught that mistake. Let's flip that over before I commit us to too many changes here. All right. So if I'm touching a wall block, if I've moved forward and ahead of myself and changed, I'm going to change my Y by 16 and look above, and then check and see if I'm not touching a wall block. So let's go grab a not operator, and we'll put the touching wall block in there. So if I'm not touching a wall block in the block above where I'm stepping, that means I can start to climb. So I'm going to change my Y. Change Y by 2 here. So that will rise me up. And because we're going up and we actually want to go up, we're going to change our gravity this frame. Let's set gravity this frame to 0 so that we don't bring ourselves back down again. We actually want to climb this block. All right. So now we've probed upwards. Before we go on to anything else, we have to move our probe back down again. So let's go change our Y by minus 16. That'll bring us back to that spot in front of our character. Good, so that's the first part of this probing here. We're checking to see if there's a wall to climb and then climbing it. If there's no wall block in front of us, then we'll do something different. We still want to check above us because there might be a wall block above us and not one to the right of us. So in this case, if there's not a wall block in front of us, we still want to probe here. So even in this other case, we still want to change our Y by 16. And we're actually going to do the same thing if not touching wall block. So I'm just going to duplicate this block here. So we'll grab an if statement here. If not touching wall block. So if there's no wall block in either spot in front of us, then we can actually do a permanent move here. We're going to move forward just by 0.2 steps. So all the moving and changing of our X's and Y's here, none of it's actually going to stick. And we always move backwards. We're popping forward, checking something, then moving backwards. But this is the move that's going to stick. And of course, if we're climbing, that part's going to stick as well. Even though we're going up and down, this change Y here, we haven't moved it back down again. So that's going to stick here. Okay, change. And so now that we've done our forward move, we're gonna get rid of our probe. We're going to change our Y by minus 16. So we're just resetting things. Just like we did at the end of this one, we're going to move back down to ground level again by changing our y by 16. Then we're going to move minus 6 steps. So we're actually outside of the if-else. This is going to happen no matter what happens. We still, at the end of all of this, want to move backwards minus 6 steps. So we probed forward, we probed up, then we have to go back down and to the left to end up back in our starting position. Except we're 0.2 steps forward now if we were actually walking, or we're 2 pixels up in this case if we're climbing. Okay. And now if we're up in the air, the last thing we want to check here is if we have to come back down again here. So I'm going to go if gravity to this frame is equal to 1. And there's a variable called gravity this frame. If gravity is turned on, which means if we're not climbing a wall, then we need to sink back down to the ground again. And this will only usually apply after we finish climbing and gotten to the other side of our brick here. So let's go make a new block. We'll call it gravity. Let's click OK. All right, so now we have a new gravity block, and we're just going to check and see if we're going down here. Okay. So yeah, I think we'll actually work on the gravity block next, which will determine us going down. And then we actually, maybe we can give this a test right now before we do the gravity, just to see if it's actually working properly. So let's click the green flag. I'm going to mine some dirt while I'm waiting for my zombies to appear. There's my first zombie coming up on the right here. I'm going to put a single block here and see if he climbs it. Then I will do a layer of 2 blocks and see if he can't climb it. So let's just, yeah, here he goes. He's climbing, moving forward. Now he's not coming down again though, because the gravity's not turned on. So that's our next step here, is to turn gravity on. Okay, so this gravity function here is mostly about probing again. We're going to be looking forward in front of us and down below us to see if there's walls, and that will determine whether we're moving downward or not. So we're going to start by changing our y temporarily by 1. We're going to go change y by -1. That will probe us downward a little bit, where we're going to check and see if there's a wall block right down below us. So let's go control if not touching a wall block. I'll grab a not and touching wall block. If I'm not touching a wall block, we're going to change our y by -1. So we'll start to fall here. Change y by -1. And then we're going to move forward 6 steps, which will take us into the next block. And we're going to check and see if now we're touching a wall block. So let's go if touching wall block again. Wall block. If we're touching a wall block here, we're going to change our y by 1. That'll move us back up again. Now we're going to move back again, so move -6 steps back to our starting position here. We're going to change our y here again by 1. So no matter what happens with this if statement, we're still going to change our y by 1 and go up. And I believe because we're still climbing here. But if we've moved down, if gravity has pulled us down to ground level, which is a y of around 52, so if I go if y position is less, let's grab a y position from our motion blocks. If y position is less than ground level, which is 52, then we're just going to set our y position back to 52, and that'll stop him. No matter what else happens, he'll never go below 52 that way. All right, so this is a little bit confusing here. We were just probing forward and looking for walls and stuff, but let me show you how it actually works. We'll click our green flag and wait for our zombies. While I'm waiting, I will mine some resources. Okay, here's the first zombie customer on the left here, so I'm going to put 1 block here, and then 2 blocks up there, and we'll watch this happen. So now gravity should kick in. Our guy will climb, move forward, and when he no longer detects anything below him, he'll start coming back down again. There we go. But he comes to the second block, sees that there's something in front of him, and now there's trouble. He can't go any further. So we can use these walls to hinder the forward momentum of our zombies. There we go. That's too late to stop that zombie. But that other one will be stopped here. Okay, so these zombies are going to keep piling up. Later on, in another episode or two, I'm going to show you how the really cool system we have to make it so that when you hit these guys, only one of them ends up getting hit by an arrow. And so you're going to have to use multiple arrows when we get these guys stacked up on top of each other like that. But that is a subject for a different episode. So the poor zombies are stuck here, and it seems like the advantage is with my character, but there's some other characters appearing on the screen in a little bit, including a creeper who's going to blow up these walls, and an enderman who's going to be walking up and carrying these ladders over that are going to allow your character, the zombies, to climb the walls and get back to you again. So something to look forward to in future episodes here. Okay, so we got a little bit of time to spare here. We're doing well. So I'm not going to finish coding this zombie right now. The rest of the code all has to do with the zombie getting damaged by arrows, and our arrows aren't implemented yet. So I'm going to save all of that till later. And let's just start getting some new creatures on the screen here. I'm going to move on to the creeper character, which you can see right here. The creeper has a bunch of different costumes. Normal movement costumes. Oh, I'm zoomed right in here. You can't see anything. There we are. So there's our creeper's movement costumes. You see that he cycled through those. These are ripped straight from Minecraft as well. And you can see there's some exploding graphics here. Quite a few of them. For when the creeper eventually explodes. And it gets darker and then starts to fade away. Nice little explosion graphic here. All right, so we're going to do, because these creepers behave a lot like zombies, we're going to steal a bunch of code from the zombie. We're just going to do that with a drag and drop. Let's start with this when green flag clicked. I'm just going to drag it over on top of the zombie character. You'll see when I move it on top, there's a little wiggle that the sprite gives, and that tells you that you're overlapping properly. Now, we're not looking at the block, we're looking at my finger, right, which will turn, my arrow will turn to a finger when I'm on top of the zombie, or on top of the creeper, then I let go. And if we go over to the creeper here, you'll see that indeed the code has been copied over. Now, a couple of things we need to change here underneath the hide. We're going to switch costume here to Minecraft Creeper. We don't want him wearing an explosion costume when he gets created here. The graphic's a little bit big here, so we're going to set size to 60%. And then we'll just shrink him down to the appropriate size. And we don't want him spawning every 6 seconds. We want him to wait a bit before appearing, so we're going to have him appear every 12 seconds. You could make this a random number if you wanted to mix the game up a little bit. Feel free to do that. Okay, so now let's go back to the zombie, and we'll grab the when I started the clone code and drag that over to the creeper. Now, again, there's a few things we have to modify here to make it work properly. First of all, we have a new variable here, and it's called explode counter. And that is a local variable again. So each creeper will have its own explode counter. Let's set explode counter. And explode counter is basically the countdown to when our zombie blows himself up. We're going to set that number to 80 at the starting point here. And so when our creeper touches a wall, it's going to start a countdown, after which he's going to blow up and destroy the wall in front of him, hopefully. All right. The pick random part is all good here. I don't think there's anything else we have to change. Oh, we do have to change a costume down here a little lower. If costume name equals probe, we're going to switch to Minecraft Creeper. There is a probe costume here inside this creeper, so we don't have to worry about changing the rest of the code here. All right. I think we're good to go here. Now, because I dragged these custom blocks, this block over that had custom blocks in it, if you go back to your My Blocks here, you will see that the custom blocks do not carry over with the original one. So we're going to have to drag those custom blocks over as well so that they actually have a proper definition over here on this side as well. So let's go back to our zombie. And I'm going to grab the move blocks and drag them over to the creeper. And I'll drag those empty ones as well. Oh, the gravity one as well. Over to the creeper. And the two empty ones, check for damage and die. We're going to move those both over as well, and we'll just move the code later. Okay, so back to our creeper. Let's clean this up a little bit. We're making a big mess on our screen by dragging and dropping stuff. Move the gravity over here. Okay, that's looking a little tidier now. Okay, so this custom move block also needs some modification here, and that's going to be, that modification is going to be to make our creeper explode when he's touching a wall rather than trying to climb it. So in order to pull this off, we need to go to this first if statement here, if touching wall block. And inside there, the second if statement that says if not touching wall block. We're going to pull that out. It's a little bit complicated. And we're going to replace it with an if-else statement. So let's go to our control blocks. We'll grab an if-else and put it inside that first else statement. We can take all the contents of the if and put it back at the beginning of this if statement. We also need to take this final change y by -16 and put it right before the second else, so outside this else statement and before this one. Yeah, that's the spot. And inside here, we're going to put a new custom block that's called Act as Creeper. And that's going to be the one that actually explodes it. Let me just double check and see. No, this one doesn't run without screen refresh. So let's go make a new block here called Act as Creeper. And that will be the explosion block. We're going to tell it to do that. So that's going to be activated if I'm against a wall here, basically, right? So let's go Act as Creeper. Let's actually run that animation now, because that will be a fun thing to end on here. So this is, I think, the last thing we're going to do here today. So if we're touching a wall, we're going to change explode counter. Let's go to our variables. We'll change explode counter by -1. If explode counter is less than 0, so if our counter runs down, that's when bad things are going to happen. Let's go drop that variable explode counter into there. So if our explode counter runs down, we're going to do a couple things here. Let's start in our looks commands here. We're going to go clear graphic effects. That'll get rid of that red look if these guys have been injured once. We're going to set our size to 30%. Our explosion graphic is very big, so we're going to have to shrink it. We're going to switch our costume to explosion GIF. So this is an animation that Jeffrey imported in here into the creeper graphic that will have him exploding. We're going to go to the front layer to make sure that this explosion happens on top of all the other action in the game here. Go to front layer. And we have to recenter this guy because the explosion's not quite in the right location. So we're going to change Y by 75. This is all positioning that explosion properly on the screen. Now let's do a repeat until, which is the kind of control block that'll just repeat around this loop and keep spinning until we get to costume number 30. So let's grab an equal sign and pop it in there. And we'll go to our looks. We'll pick costume number bubble equals 30. When we get to costume 30, until we get to costume 30, we're going to go next costume. Then at the end of the explosion, we're going to wait 1 second. Wait 1 second. And then we're going to delete the clone. Under control here, delete this clone. That'll get rid of the remnants of the creeper. All right. And the last thing we're going to do here, I'm surprised there's no sound effect in here. Oh, okay, yeah. So the sound effect's going to be done elsewhere. All right, I'm going to leave this here. We're going to add a little bit later on that I'm going to explain in a second here. But let's do a second when I started the clone here. And this is going to govern the sound effects of the creeper. Because the explosion sound actually is a combination sound. Let me play the sound for you here. It's actually the creeper reacting first, doing a little sound, and then the explosion. So this sound, let me play it for you. So it's kind of that lightning sound first, and then the explosion. But because this is all in one sound, we can't have this happening at the same time that the explosion is triggered. It has to start earlier, and that's why we're doing a second loop here. We're checking to see if the explode counter is less than 70. So before the actual explosion happens, and let's go grab explode counter. Then we're going to play the sound until done. So let's go to our sounds, play sound, creeper explosion, until it's done. And then we're going to just stop this script. Stop this script. There we go. Oh, I still got those explosions happening. Stop! I'm stuck in an endless loop here because I haven't added that stop this script yet. There we go. Okay, so that will start the explosion happening a little bit sooner. I don't know if I've remembered to code everything here. Let's have a quick look. Wait for our first... Let's gather some stone while we're waiting for our first creeper to appear here. Okay, we'll put our first wall up here. We'll put another wall on the other side here. Need to mine some more rock. There we go. And here comes our creeper. So our zombie stuck on the wall. Let's see how our creeper does. Touches the wall. Sound. And then boom! He explodes himself. Now we don't have the wall getting destroyed yet. We'll deal with that later. But that's a promising sign here. The creeper is exploding the way we expect it to. Let's get that second touch. Boom! That is a lovely explosion. I must say, very satisfying. So we've got our creepers blowing up. We're not going to take out the wall in front of us yet. That's something we're going to do in a future section here. But I do want to add one more little visual flourish that is going to make this look a lot more like OG Minecraft. So what I want to do is have that creeper, before it explodes, kind of pulsate, get brighter, and then get back to normal, and get brighter, and then back to normal. There is a visual effect here called change brightness effect, that we can use. The problem is we want this to go up and then go down, which means that we have to keep track of what the current number is. There's no block, though, in Scratch that tells us what the brightness of character is. We can find out what its XY position is, and we can find out a few other attributes of it, but there's no block that reports back to us what is the brightness of this character. So to get around that problem, we're going to have to create a new variable called brightness and feed that into here. So I'm going to go make a variable. I'm going to go for this sprite only because we want a different brightness factor for each of our clones. And I'm just going to call this brightness. There we go. Or you can call it something different if you like, if that confuses you too much. All right, so we want to initialize that brightness. We'll do it right here when I start the clone. So as soon as the clone is born, we'll set its brightness to 0, which is the default brightness. And then we're going to set that brightness effect to match whatever that variable is. So we're going to do it right here under Act of the Creeper. We're going through here and kind of looping around through here over and over again, changing that explode counter by -1 every time this block gets invoked. So right in here, we're going to set brightness effect to match the brightness. So we'll just go into our variables and we'll add a brightness in there. So now it'll match whatever that number is, and now we can change that number. So let's change brightness by 1. Now it'll go up. And the last thing we're going to do is just if it goes up beyond a certain point, let's do it 25 times here. So we'll go if, so we have to do that before our other if statement. If brightness is greater than 25, let's call it 25 and see what that looks like. So we'll go to variables, we'll grab a brightness. So if brightness is greater than 25, then we just set that variable back to 0 again. So this is what will make it pulsate. It'll go up by 25, then back down to 0, up by 25, then back down to 0. And sometime during the third time getting brighter is when it'll explode. Let's give that a try and see how it works. We don't need to actually view the brightness factor here. There we go. So let's maximize our game and give her a try. Let me harvest some resources while I'm waiting for my creepers to show up. Need that stone. Alright, there's my first creeper on the left. I'm going to do a double high block here, which will stop him in his tracks and get him to explode, and we'll see if he changes color here as well. I'll do a second block over on the right as well. So here we go, and he glows, and then boom, on the third time. Beautiful. Let's watch it again with this guy over here. He hits the wall, starts to glow, and boom, he blows himself up. Beautiful. Okay, so we're still going to take out those blocks, as I said. That's something that we're going to save for a later chapter. But we're making good progress on our game. This is a massive game project, though, I warn you. We're going to be at this for probably 4 or 5 sessions or so. We're still kind of mapping out how we're going to teach this. So be patient with us, guys, and we will get through this as time goes on. So I hope you enjoyed Chapter 2 of our Minecraft Tower Defense game. And we will be back next week with Part 3, where we're going to add the archers and the bow and arrow feature. And that's going to be a fairly complex thing. And then we can actually start shooting some of these bad guys. After that, we're going to add the Enderman, who's going to bring ladders to the scene. And then we're going to be doing a boss fight where we can exit this screen, go to the end portal, and fight the Ender Dragon. So that's really exciting, and that's coming up in future weeks. So hope you're enjoying this series. Drop us a comment if you're having fun, and give us some suggestions for what else you'd like to see us cover. Thanks, guys, and we'll see you next time.